Hello and welcome. My name is Rachel Barber. I am a coordinator for COVID-19 related research at the MIT Media Lab, and I'm excited to welcome you here today to this webinar, Encrypted Vaccination Cards and Digital Solutions to Empower Citizens in the Vaccine Rollout, hosted by Trusted Pandemic Technologies at the MIT Media Lab and the Auto ID Labs. We're very glad you could join us. And now I'd like to introduce Professor Ramesh Raskar, who will walk through our agenda for today and introduce you to your speakers.
Thank you, Rachel. Today we are here to talk about trusted pandemic technologies and specifically about vaccination coordination. We invite you to join our website at pandemic.mit.edu. And also join the conversation on our Slack channel at tiny.cc/PathCheck Slack. And then you can join the vaccine discussion channel. The Slack channel is a great place to network, get to know each other, and also share any comments for potential collaboration. I'm going to start off the conversation about vaccination protocols that avoid the red tape. Then we have a fantastic set of speakers. Sanjay Sharma from MIT, Anna Lezinskaya from Brown University, and Abhishek Singh from MIT about the vaccination protocol and digital certificates. James Smalls from Ideo about designing a new vaccination card. Vittorio Pamplona from PathCheck Foundation for the Boost 19 app that can be used to implement this protocol. Brian Anderson from MITRE, presenting about the Vaccine Credentials Initiative, and then Brian Bellendorf from Linux Foundation talking about the COVID Credentials Initiative. So let's talk about creating vaccination protocols that avoid the red tape. And this is a decentralized vaccine coordination that we would like to discuss to create digital tools, in this case apps, to empower citizens that can augment the CDC and state systems such as vSafe and VAMPS and IIS. And our goal is to present the standards, architecture, the open source code, and algorithms that improve efficiency, privacy, equity, and trust. And there are two parts to this. One is an augmentation of vaccination cards that does not require any app at all. So you don't have to be tech savvy to use these vaccination cards. And second is a full-fledged app that can boost privacy, but also provide real-time privacy-preserving aggregation. And our focus is on the full user journey, from eligibility to second dose coordination to health verification to reporting of symptoms. The challenges in the current approach, the challenges overall in vaccination is eligibility. How do we decide, who is eligible in this phased vaccination and prioritization and scheduling? The second is coordination between first and second dose. How do you make sure that you're scheduling folks for second dose? If they got the Pfizer, they also get a Pfizer for the second dose, and there is no mix-up. And how do you do record linkage between the users? The third is this notion of health passports for entry permits. And finally, how do you monitor outcomes, effectiveness and safety in the short term and the long run? And there's some really wonderful solutions that are already deployed by the federal and state entities, such as Vaccine Administration Management System, Vaccine Adverse Event Reporting System, the vSafe system, the Immunization Information Systems, and so on. So what are we talking about here? We're talking about how can we improve the vaccination card in the first step to dramatically improve the efficiency, privacy, and equity. So this is a partnership with Ideo and PathCheck Foundation, where this vaccination card will improve the user journey through encryption, at the same time create a data-rich vaccine monitoring solutions on a dashboard. And as I said, it looks at the whole user journey. So these are concepts by Ideo that we are working with. And these cards would look like an ordinary vaccination card, but you can add stickers at different phases. And some ideas include twofold cards and trifold cards. And James Smalls later on from Ideo will come and discuss how these solutions look like and the design parameters behind them. And then the vaccination cards on one side have instructions, but the other side has all the information about the coupons and badges that I'll talk about in a minute. So this is kind of a proposal to augment an existing CDC card with stickers. And there are 4 types of stickers: the coupon, the badge, the status, and passkey. So let's talk about that for a second. And you'll hear more from Anna Lizinskaya and Abhishek Singh about the protocol itself. So for these 4 touch points in a user's journey, eligibility of vaccination would be solved through coupons that are sent by an employer or city officials. In terms of dosing at a clinic or a mass vaccination site, you would get a badge after the dose is complete. You would get another sticker called status that can be used for entry to the venues or public facilities, which is similar to health passport. And finally, for monitoring for safety and efficacy, again, the badge information can be used for authenticated uploads. So the top row indicates here what a user journey would look like. And as you can see, for the user, there is no use of technology at all. No phone or websites or apps, only the vaccination card and stickers. And at the bottom, different individuals, the employer, the vaccinator, the guard, the caregiver, would use a accompanying scanner app that we'll discuss later, that will take you through that journey as well. And the particular protocol itself uses the idea of digital certificates. So again, the scanner app does not have to have a live internet access. At the same time, the mechanism is tamper-proof. So using these 4 QR codes, coupon, badge, status, and passkey, that we'll discuss later in presentation by Anna and Abhishek, we can provide an end-to-end user journey and at the same time aggregation of this data. So what are some main ideas here? So one idea here is that we should start sending this unique vaccination cards to everybody right now, like a mail-in ballot or a census form, or like you would buy a ticket from Ticketmaster. Everybody should get a unique vaccination card right now. Pre-verify, and create a pseudo identifier for everyone. Then on the bottom left is, let's get rid of the name and date of birth and personally identifiable information for an index for a lookup. Instead, let's use digitally certified coupon number, which effectively becomes your new a new pseudo identifier, a new social security number for the sake of vaccination. And that certificate is difficult to tamper because it will say the coupon can only be used in Springfield, Oklahoma, in phase 1B by a teacher. And then on the top right is, let user provide the record linkage, and let's not expect the disparate health IT systems to connect with each other, because they're creating data silos as they had to carry PII, and not all the systems are in place. And then use the user provided record linkage for real-time triangulation and dashboards. And finally, for uploads to CDC or any kind of adverse reaction systems to even pharma players, let's make them verified using verifiable credentials so that there's minimum user friction. It's a single click or single phone call with their badge information, and we can reduce the fraud, or we can reduce misinformation that could be uploaded and noisy information that can reduce trust in the system. So our goal really here is efficiency, privacy, equity, and trust at these 4 touch points in a user's journey. And in these detailed slides, as you can see, right now, in terms of eligibility, there's an anxious wait, there's a scramble for scheduling slots, there are concerns of people jumping the queue. And the way you can solve that is if you pre-verify right now, in phase 1A, B, C, phase 2A, B, C, phase 3, if you can give everybody a vaccination card right now with a coupon, and whatever the clumsy mechanism you need to validate you're a teacher or a childcare worker, and so on. All those things can be taken care of right now with a unique code, and no centralization of PI is required. In terms of dosing, right now at vaccination sites, everything happens on site. It's a manned workflow. The eligibility of age, job, or health risk is all assessed on site. It's looked up with name and date of birth. The risk questions of allergy is asked on the spot to decide whether you should go to a green lane or a red lane. Second dose appointments, all of these are being done at vaccination sites. And as Sanjay Sharma will talk about, we need to decouple the qualification from delivery. Entry permits will have a lot of conversations. Handwritten cards are good, but they reveal sensitive data. They're forgeable. And in terms of monitoring, there's always a challenge of unverified self-reports and it's difficult to track data on ineffective lots. So a lot of these challenges can be addressed by using verified codes for the user journey. Some common questions are we just talking about physical cards? Why can't the same codes be sent over SMS and other mechanisms? So the answer is yes. We can use all these other mechanisms also to send a bitmap images by print or through an app or through a website and so on. So when we talk about a card, we're talking about bitmap images. Nevertheless, we think a significant fraction of population just would use the paper cards. What about contacting subjects without knowing PII? One health expert I talked to is like, I can't imagine jabbing somebody without knowing their name or date of birth. Again, we have to kind of get outside that mode to improve efficiency. Is this a health passport? No, it's for the whole user journey, including eligibility, dosing, the verification, and health monitoring. So there is a piece of health passport, but we're talking about the whole user journey. What if the cards are lost? How do we solve that? And we can go into the detail. And is there a fraud? Can these coupons or badges be given to other people? And of course, these certificates that are tied to your government issued ID. So there is minimal chances of fraud. So these last mile problems is what we're talking about here. And there's plenty of reference material. Check out our GitHub, protocols for end-to-end workflows, conferences that are coming up at pandemic.mit.edu, and of course, join our Slack channel at tiny.cc/PathCheck Slack. I should also mention that on the app side, although today we're talking about the paper card, we're partnering with PathCheck Foundation and many others, which is a spin-off from MIT, and it's the official exposure notification app in actually 6 US states and territories, and also the world's largest open source nonprofit. And PathCheck Foundation, as Vitor Pamplona will present in a few minutes, is also launching an app and a scanner app to go with either the paper cards or the user-facing app as well. So I won't play the video, but download the app online. Another interesting part of this mechanism is that we can create aggregate analytics through triangulating this data coming either from the paper cards or from the apps. That's privacy preserving. And Abhishek Singh will talk about how we can use ideas like differential privacy and secure multi-party computation to achieve this type of privacy preserving aggregation. So to conclude, I think we can achieve decentralization of PII, but centralization of health data. We can augment the current efforts by CDC and states to improve the standards and architecture. And I presented 2 concepts, one based on vaccination cards, no app required for the user, and one based on an app protocol that still allows us to maintain privacy, efficiency, and equity with private aggregation. And again, to emphasize, this is about the whole user journey, eligibility, second dose, verification passports, and symptoms. Thank you. So with that, let me transition to our second speaker, Sanjay Sharma, who's the VP of Open Learning at MIT. And if you're joining now, please check our website, pandemic.mit.edu, and also our Slack channel, tiny.cc/PathCheck Slack. Sanjay.
Thank you, Ramesh. If you look at the way in which we get regular vaccines, for example, a flu vaccine, You go to your doctor and you say, listen, I think I should get the flu vaccine, or they might suggest it to you, and you just go down to your local CVS. Maybe you sign a couple of waivers, but you could pay cash if you want to get your vaccine, and you leave just as if you'd purchased a bottle of Tylenol. There is no centralization. You're not submitting stuff to a massive database. Your doctor isn't talking to this database. You just got it, you know? Now, there are two fundamental differences, of course, in this strange time. On the one hand, we have a vaccine that's in very short supply. And so what that means is that we have a very nuanced classification of who gets a vaccine when. We know all this phase 1, phase 2, et cetera. It's based on your job, and it's based on your age and pre-existing conditions. And we have no classical way for proving this. For example, if your job is you're a childcare worker, how do you prove you're a childcare worker? So what this has done is this vaccine situation is for two reasons creating a push to centralize information. The first of them is that when you show up to get your vaccine, you got to prove that you are in the category that can receive the vaccine at that period in time. And that's one push to centralization. It's almost like we're trying to fill thimbles with a fire hose, it's sort of so awkward. And so that's one thing. The second thing that's pushing centralization is that the logistics of vaccines are very difficult. The cold chain of Pfizer, as you know, is extreme. It's negative 70 degrees centigrade. And if you open a box, if you open a vial, you have only a few hours to use it. So you want people together so you can sort of pump them through the system and get the vaccine to them. And even Moderna is negative 20 degrees centigrade, which is much better, but still it's not a room temperature. And so there's, again, a push towards centralization. And so the problem is that this push towards centralization and data centralization are being coupled, and that is unfortunate. So what we are suggesting, what Ramesh just very eloquently described, and what Anna and the other speakers will talk about, is we need to decouple. This is not a scalable situation. The way you decouple is you give people coupons. If you're a firefighter, you get a coupon that says you're a firefighter. If you are a person with two pre-existing conditions, you're elderly and you're diabetic and you have some other issue, you're on chemotherapy, that is something between you and your doctor, and the doctor gives you a coupon and says, you can receive the vaccine. And then if you can separate the coupon issuance, then the actual vaccination process can operate in a way that we know how to do it, which is you set up massive, stadiums or like flu clinics, except much larger, where the cold chain limitations can be accommodated. There can be a village clinic, and people come there aggregated with their coupons, and all they do is show their coupon, they get the vaccine, they leave. And the beauty of this is you let the logistics people do the logistics well, and you let the issuing authority give you your coupon independently, and each can do it in a decoupled way, and we have a shot at actually killing many birds with one stone. We can get scale, we can pump people through, we can parallelize the qualification, we can make it parallel. We are right now making it, we're coupling them, and so we make it sequential and slowing things down. And perhaps most importantly, the thing I'm most concerned about is privacy. Because when you pump a lot of information into a central server, into any central database, it can be, of course, abused, and there's concerns. I talk about vaccine hesitancy is only one step. I think digital hesitancy is going to be another confounding factor. But on the other hand, there are hackers out there who would frankly love to get that information, get this information. And in this slapdash urgent approach where we throw all this information into the database, I think we're putting all our eggs in one basket. Forgive me for mixing my metaphors, and setting ourselves up for a real problem. So these are the reasons. I say this as someone who's worked in logistics for many years, and in standards for many years, in privacy for many years, that I believe that this decoupling that Ramesh is describing is essential and perhaps existential. Vaccine hesitancy, digital hesitancy, logistics. We need to separate the three. Ramesh, back to you.
Thank you, Sanjay. Can you, just a quick question for Sanjay. Given your experience in setting up the standards for RFID and Auto ID Lab, what parallels do you see in terms of the ecosystem coming together to improve efficiency? Back then it was more about trade secrets. Here it's more about privacy. What parallel do you see from the challenges in early 2000 to get barcodes and RFIDs distributed and agreed upon versus the system we have right now? For example, even Pfizer and Moderna don't agree on the QR codes for the vials yet. And then we have, of course, have these downstream challenges with the user journey itself.
I think, Ramesh, there are actually lots of similarities. So one of the things we did with RFID, with the Audio ID Center, is we separated the issuance authority, which is, so let's say that you have an RFID tag, you put a number in it. It's a number we made up. We call it the electronic product code. And the problem is that if two companies put the same electronic product code, then you have a collision. And so what we created was a separation of the issuance authority from the manufacturing of the tag to putting that number on the tag. And that issuance authority is now standardized, and it is now owned by a nonprofit entity I sit on the board of. It's called GS1. These are the people who do barcodes worldwide. And we also made it an ISO standard. But a central tenet, in my view, of good standards is a good architecture, a decoupled architecture, an architecture that can survive. If you couple things, it can't survive one error, right? I mean, if someone shows up and says, I'm a firefighter, but they're not, the queue gets delayed, and maybe the firefighter's database gets hacked, there's another problem. So you have to have a robust architecture to have robust standards. So those are the similarities, Ramesh.
I appreciate that. Thanks, Sanjay. Switching over to the next presentation by Annalise Skaya, professor at Brown University, and Abhishek Singh at MIT on the cryptographic protocol for this user journey. Handing it over to Anna and Abhishek.
Hi, everyone. Let me share my screen. So I'm going to present the mechanics, what's happening under the hood. Assuming you can see my screen, right?
Yes, go ahead.
Okay, good. So what are the mechanics under the hood, things that are happening? So so first of all, let's focus on the problem statement. So what we want is at every stage of the vaccination journey, just as Ramesh said, we want the user to have something, some credential that they can show to, that they can use at this step. So at first, in the first stage, you have a proof of eligibility. Then you have a proof of partial or full vaccination. And potentially, if you have symptoms, then you need proof that that what you're submitting, that the symptoms you're submitting to the system are actually linked to the relevant vaccine. So what does that mean? We want these proofs to be hard to forge and hard to transfer to another user. So, and we want them to be very usable. So there are two types of proofs that we are currently looking at. One is something that fits on a piece of paper, so it's like a QR code. And the other one is based on an app, so that your device will do a lot of the work in presenting this proof. And of course, we're focusing, so both of these have to be machine readable. And a lot of the details are up for discussion. So one thing that's up for discussion is who actually issues these badges, these coupons. Is it the pharmacy or the state or the CDC? So those things potentially can be discussed. Right now, we're thinking that it's the CDC that provides the infrastructure for these, just so that everything is streamlined and similar. So the user has such a proof, can present it as needed, and there is no central database where there's a huge, there's no centrally aggregated personally identifiable information, so that you cannot have just one database where anybody's vaccination status can be stored. That's not what we want. We want a more privacy-preserving scenario. And of course, we want to make sure that the human effort is focused on the vaccination itself, so that everything that's has to do with issuing these credentials, verifying these credentials, happens behind the scenes and doesn't need everybody to be online all the time. So those are our goals. So what is our tool? So the main technical tool to meet these goals is a cryptographic signature scheme, so digital signature scheme. So if you've been following how the internet works, then you probably already know that a digital signature scheme is this amazing mathematical discovery that you use every time that you browse the web. So the S in your HTTPS stands for secure. So how does your browser knows that it's connecting to the server that you think it's connecting to? It checks the digital signature on this server's certificate, right? So your browser downloads the certificate of the site that it's connecting to. It verifies that the certificate has a valid digital signature, and then it uses that certificate to make sure that all the bits that it receives correspond to the owner of the certificate. So the tool powering all of that as you're browsing the web is a digital signature scheme. So this is exactly the same tool that we're proposing to use in this application. And how does it work? Well, I'm not going to tell you really how it works mathematically, but just in a nutshell, it consists of 3 algorithms. There's an algorithm that sets up these keys. So there's a key, a secret key, a signing key that you need every time you issue a digital signature. And you need to keep it secret, because if you lose it, then anybody will be able to issue your signature. And then there's a verification key that is needed for verification, and that one gets published. So, for example, the CDC can run this key generation algorithm, set up a signing key that it uses to sign the coupons that it can use to sign the badge, and then everybody has access to the verification key, so everybody can verify the coupon and everybody can verify the badge. So that's the first algorithm, key generation. Then there's a signing algorithm that needs the secret key, and you tell it what it is that you want to sign, and it produces a signature. And the verification algorithm that verifies a signature on a given message under the given verification key. And the point of a digital signature scheme is that it is unforgeable. So it is computationally difficult, infeasible to create a digital signature unless you have the corresponding signing key. So that's a very, very powerful tool. So let's see in context, how are we going to use it here? How do we propose to use it? So here's our Strawman Protocol. So you have, there are several types of credentials. What do they look like? So your coupon, which is what allows you to obtain the vaccination in the first place, to get a shot, is just a signature that says, this is a coupon for this zip code, for this type of job, and there's a serial number I, and it is signed by, let's say, the CDC, so that you can present it, and it doesn't have a user's name on it, and potentially it's distributed via an employer or in some way that isn't connected to the user's actual identity. But the user goes to a vaccination site, such as a pharmacy, and presents this coupon. The pharmacy verifies that it's a valid coupon by running the verification algorithm of the signature scheme, and is ready to administer the vaccination. And of course, all of this is happening, it's automated. So the individual simply says, here's my QR code, and the pharmacist just scans it, and then the pharmacy's app says, sure, vaccinate this person, and there we go, and the user gets vaccinated. So badge is now a particular person got got a particular type of a vaccine. Sorry, the badge is attesting that the person who's presenting it got a particular type of vaccine. This is the first dose. So it's similar. And then the most interesting one, which is in the second row on the right-hand side, the passkey, that's the one that the user will go and show to a venue to prove that that they have been vaccinated. And that one now includes the user's personally identifiable information. And the reason for that is that when you present it, the venue might say, well, is this really your pass, or is this somebody else's? So because over there you have this identifiable user's personally identifiable information, the venue will be able to check that QR code against the user's ID. So we'll make sure that it's correct user. However, you might say, well, whoever issued this must have the user's PII. And the way we get around that is that information is not actually presented to the signer, which in this case is the CDC, in the clear. Instead, it is hashed down together with some random random key in such a way that when the CDC issues the badge, so the badge is above, so that's in the first row on the right-hand side is the badge. When the CDC issues this badge, the CDC does not know who the user is, does not receive any personally identifiable information, simply receives this passkey and happily, sorry, not the passkey itself, but the hashed down version of the passkey and happily signs it. So this way, the CDC can issue these vaccination credentials without collecting personally identifiable information. Just knows this is the type of vaccine that was administered. And of course, there has to be a link, right? The CDC must have some amount of confidence that it issued the badge to a valid user. So this is where we have to trust that the vaccination site, the pharmacy, is actually connecting the dots and making sure that the information that is hashed down and then signed by the CDC accurately reflects the user's information. And we're placing this trust in the pharmacy, but it isn't, it's up for debate, of course, it isn't too much trust because, of course, when you are there in person, the pharmacy already knows that you are there in person. They potentially know who you are anyway. And also they're trusted by the CDC to administer the vaccine. So they can also be trusted to correctly verify your ID and make sure that the correct identifying information gets inserted into this field for the passkey. Okay, so those are the nuts and bolts. And of course, what is very desirable, and luckily the state-of-the-art cryptographic digital signature scheme allow this, is that a digital signature should fit in the QR code. And luckily that is possible as well. Okay, so now our user goes, let's say, to the airport and wants to convince the ticketing, the gate check, the agent at the gate that they have been vaccinated, so that they're clear to fly. So they can just show this QR code. And the venue will run the signature verification protocol to make sure that this user is in fact that presenting the correct credential and their PII matches what's on their ID. Now, it is possible that instead of a QR code, we want to do something a little bit more sophisticated, like an app. And of course, an app can also display a QR code. So this paper-based solution also translates into an app very easily. Okay, so now the question is, this strawman, this QR-based proposal that I just showed you, does it solve the problem that I described in the first slide? And so our goal was to make sure that these credentials were ubiquitous, and they attested a user's either eligibility to receive vaccination or vaccination status. So we wanted to make sure that this proof that the user received is hard to forge or transfer to another user. That is that property is exactly what is satisfied by a digital signature scheme. So that much we can be we can have confidence that we got this one right. Of course, what's up for discussion is who issues the badge. So who is running this cryptographic algorithm for signing? And the way I just presented it is we assume that it's the CDC. So the CDC is connected to the pharmacy. So when the pharmacy administers the vaccine, there's a live connection between the pharmacy and the CDC. The pharmacy says, here's what you need to sign for this vaccination. And the CDC responds with a signature. And that is potentially up for discussion. And in fact, it's a good idea to try to get this one right, because there are pros and cons to this scenario. The pro is that there's just one verification key, the one that's associated with the CDC, and one secret key, one signing key, that the CDC signing key. And we only just need to worry about the CDC keeping its signing key private, and everything is fine. But the disadvantage is that, of course, there's all this, you have to be connected to the CDC all the time. And so it makes it harder to have some kind of a mobile vaccination drive where the connectivity is not as good. So that can be mitigated, but it's up for discussion. So one way to mitigate it is to say, well, the pharmacy itself can issue these signatures, and the pharmacy can be certified to do that by the CDC. And so this is up for discussion. And you can also imagine that there might be other tiers like the state. So, okay, so that's that bullet I've addressed. So can the user present this proof as needed? Yes, assuming the user doesn't lose it. So if it's tied to a piece of paper with a QR code on it, we need to make sure that there's a way for the user to maybe back it up. Maybe the pharmacy has a backup of these QR codes so that the user can say, oh, I lost mine. The pharmacy can find it based on, approximate date of when it issued it to the user. But assuming that the user, the badge is still in the user's possession, that's a fairly straightforward. And very importantly, there is no central database that records these individuals. The information that the CDC obtains in this scenario about the users is simply, this is the type of vaccine that was administered. Is this the first dose or the second dose? And that's it. So there is no central database. So you cannot have a scenario in which people are worried about the entire vaccination process because they're worried that suddenly their data is going to wind up in some central database. That worry can be dispensed with. And we want to minimize connectivity and human effort required. So most of this is automated, but this is up for discussion. Perhaps we can do better. So that's the strawman. And then there is the monitoring part of it that Abhishek will address. So I'll skip this slide for now. So note that the strawman that I just discussed was paper-based. If you have an app, things can be more interesting because now you don't need to worry about just fitting all the information in the QR code. So an app might be able to handle a lot more interesting things. So for example, we can store a lot more information so that the users, why do we even have this PII, is so that the user cannot transfer their credential to another user. So if you have an app, then potentially you don't need to show your ID, the same ID every time you use this credential. You can embed in an app, oh, this is the number of my student ID. This is some other ID. So you can kind of embed a lot of other information in there, which you show as needed. And so an organization that already knows you by a certain identifier does not need to see all of your information. It can just say, okay, I trust this identifier. Oh, and it's the same identifier as in your badge. And moreover, even more interestingly, you can make it even more privacy preserving by just, if you have an app, instead of showing the signature in the clear, the app can just prove that it has a signature without revealing any other information in a way that's unlinkable, using unlinkable anonymous credentials. And then your privacy is really protected. Or you can also do, you can also embed interesting biometrics. So if you have an app, there's a lot more interesting stuff that can happen. And also apps help on the distribution state and streaming it and monitoring, which Abhishek will talk about. So just here's a summary slide of benefits and limitations. So the benefits of this approach that I've outlined so far is that you have more privacy. There's monitoring that's possible. And and the part that the information that the CDC does keep, it allows the CDC to keep some information, just not in a way that's connected to individuals. The limitations, as I mentioned, is that the pharmacy needs to do this, it needs to verify the information before it signs it. So the pharmacy has to do a little bit of work in order to make sure that the credential that gets issued is issued correctly. Then there is in the Strawman, as I said, the venue is verifying the vaccination status, and they do need to check a user's ID in order to make sure that it's the properly vaccinated user who is presenting the badge or the credential. And this can be mitigated by, for example, if you have a biometric reader, so the user just puts his thumb to the biometric reader, and then that can make it less work for the venue, because the venue just checks does the fingerprint that the user just submitted, does that match their badge? But that approach would require that the venue has some biometric reader, whereas just using a digital signature and an app that verifies a digital signature does not assume that. And then there's also possible limitations to the privacy of the overall system, is that if you don't trust the pharmacy not to collude with the CDC or some other central entity and submit your private information, then you might still be distrustful of the overall approach. And similarly, if the venues, if every time you go somewhere, that venue kind of keeps tabs on what you're doing and submitting this information somewhere, then again, you're not going to trust that your privacy is protected, although that part can be mitigated using anonymous credentials. Okay, so with that, I am going to hand it off to Abhishek. And as I mentioned, Abhishek is going to cover this monitoring idea and other aspects of the more app-based approach.
Thanks, Dr. Anna. I'll start sharing my screen.
Yep.
Yes, so my screen visible?
Yes.
Okay. So yeah, the last stage in the whole protocol here we have is monitoring. And the idea is for every user to submit or even monitor a potential adverse reaction or any associated symptom with a given vaccine. And the way we want to do here, the way we want to make sure that user privacy is retained at the same time they can do this monitoring as well as submit their adverse reaction is through, in a privacy preserving way, is through some sort of multi-party technique, because in the end they're uploading their data and it's like a health data, so it could be sensitive. And the very simple idea here is to just take the information and send it across two aggregators. such that they can work on this, perform computation on this information at the same time, do not get to know what information exactly it is. So to put it simply, let's say if a person wants to submit 0 or 1, and where 0 means they're not feeling any symptoms at all, and 1 means they're feeling some symptoms, what would they do is they would compute some secure share. So here, again, simple example is instead of sending 1 to one server, they will send 300 to one server and minus 299 to the other server. And now what happens, similarly, many other users submit this information to 2 servers. And in the end, when they compute the sum over it, they would still have the same number, which they would have got as a single server. But at this time, no single server got to see any sensitive information from the user. Again, I'm taking very simple example of 0 and 1, but it could be much more complicated, and as well as it could also contain some personally identifiable information here. So that way we can perform some computation on this sensitive information at the same time do not reveal any identity. Now the second part here is publishing this information, because as we can see, when the data is very rich, even the aggregated information would reveal something about the population. And that could be dangerous, especially when the users are the early participants on this whole system. So for example, the first user who comes in will, of course, have to reveal their whole data in order to get the full aggregated statistic. So the way it is solved is we use some notion of plausible deniability. So the way we want to enforce this notion of plausible deniability is using either differential privacy or some other methods of secure thresholding, where the idea is that whatever aggregate computation we perform, there is some amount of noise or some sort of thresholding such that participation of any user is not revealed just by looking at the statistic which has been published by the server. And this statistic can be used in a variety of ways by CDC as well as the vaccine companies, all pharmaceutical companies, and other researchers who are trying to study potential effects, and also monitoring how the system is evolving as we keep vaccinating more and more people. So overall, again, the idea is to upload data as well as download data. At the same time, perform some computation on it without revealing any identity or personally identifiable information about the user. So this is the whole monitoring ecosystem. And then zooming out here and looking at the overall system goal is to ensure that we support end-to-end flow. So 3 goals, which we have highlighted previously also, just summing them up again. Digitization of the existing system so that we achieve some extent of efficiency, coordination, scalability, which clearly are some of the big issues right now as we see the distribution of vaccines unrolling right now. And then privacy at individual level, because we want to ensure that individuals participate, as well as there's no unintended consequence of the information which is being collected here or transferred across different systems which are coordinating with each other. And third is also very important, which is interoperability, because there's already a well-built ecosystem around some of these things, like VAMs and vSafe, and we do not want to create any disruption and be incompatible with the existing systems. And as we discussed, if you want to view this whole ecosystem, it can be broken down in 4 stages. First is distribution, where we discuss how the coupon is distributed and how we use digital signatures to verify the coupon's validity and eligibility of the user. The second phase is where vaccination happens, and the second dose coordination also happens. Again, this is the vaccination phase where the user goes to the pharmacy, gets vaccinated, receive their records, and using these records, they go to third stage where credentialing happens, and it could be used for various purposes for getting entry. And the fourth stage, which is the post-vaccination phase, where adverse event reporting and monitoring happens. So with that, I would like to conclude, and thanks for the time.
Thank you, Anna, and thank you, Abhishek, for that overview of the protocols. Next, we have James Malls from Ideo, and James and team have been working with us to design, a new new philosophy, all the way from the physical layer of the cards to the usability layer to the digital, and very soon about the integration. So James, it's been a pleasure working with you, and looking forward to your presentation.
Thank you very much. It's an honor to be here. Thank you for having me. Hopefully you can see my screen here. One moment. Okay. So when we started on this project, there had clearly been a lot of rigor put into the technical side of this, and there continues to be. And that freed us at Ideo up to start thinking about the human experience here and some of the touch points along the vaccination journey and the way that we can have some positive impact on those, keep the, the human interest at the forefront of our minds as we're designing, and then, leverage the collective input of all of the people we have to ensure that we're meeting the highest standards of accessibility and usability, and really working in a way that is iterative and fast, so that we're not being too precious about any one thing, but rather using all of the artifacts that we're surfacing to support the journey as a means of provoking conversation and asking questions and hopefully digging a little bit deeper. So while in some ways this maybe feels a little rudimentary, we always are trying to remind ourselves who we're building for. And we are anchoring around the user or the vaccine recipient experience, but in order to create the best experience for that person or those people, we also have to design all of the interactions between all of the people that they come into contact with in the process of completing a vaccination journey. So in doing that, in surfacing more artifacts that talk about each one of these moments, we begin to start kind of putting pieces together that can inform our path forward to creating something that works for a wide swath of people of different levels of literacy, different cultural backgrounds, whatever situations we can surface and imagine, we're trying to make sure that we're cognizant of those and designing for them. So one of the first places to start is thinking about what already exists. And there are already vaccination report cards related to COVID, related to other kinds of vaccines. And we've got some clearly new challenges here. But if we can start to work with something that people have a familiar framework with, maybe we can make something that doesn't feel so jarring or so new. And it allows us to begin to augment and build on top of that thing in a way that is mindful and respectful of the audiences that we're delivering to. So our early explanation or explorations already started to have some provocative results. We heard a lot about the way that we're using these different machine readable codes, QR codes, to reveal different levels of information at different moments that is really guided by the user, which is great. But how can we make those machine readable codes a little bit more bilingual? Something that is sensible to the human as well, which both protects the vaccine recipient, but also the people who are going to be distributing these codes to people, making sure they're receiving the right ones and they're using the right ones at the right moments, if that makes sense. And then, even from a very practical point of view, we have to think about the materiality of these things, the layout. How durable are these going to be if you're going to be carrying it around long term? How might they be replaceable by people if they become damaged or lost? How can you protect privacy in something that is very physical and tangible? So in some of the explorations that we've done, simple things like changing the way the folding scheme works with these cards can allow a person to obscure certain information that they may not want to show. So if I'm going to a venue and I only want to show my status badge, how can I fold and reconfigure this piece to allow that to be visible, but not something else? If I did damage or lose my piece and I want the opportunity to be able to reprint one at home, how can we format this to fit a simple 8.5 by 11 sheet of paper that can be folded in half? And now I have something that's two-sided and very closely mimics the one that you may have received in a direct mail. Talking again about the QR codes, how might we be able to embed some visuals in there, icons, symbols, and things that allow me as a person to be able to quickly glance at one of these and see, this one is my pass key, this is my status key, and so on. This also kind of feeds into the experience, again, with a health administrator. If they're doing tons of these a day, they're vaccinating lots of people, they're producing lots of these codes at their vaccination site. How can we put them in the best position to ensure that they're putting the right codes in the right places if we're using a sticker-based system, for example? So we're looking at those elements of the usability and the experiences between the vaccine recipient and all of the other players throughout this design process. And then we start getting into the digital as well. And on the left side here, we're really kind of looking at the health administrator experience. One of the things that we wanted to do was, again, thinking about what exists and what we know, how can we create an experience that feels familiar and feels simple and guided, but reinforces safety and confidence both in the administrator and the user, the vaccine recipient. So we were really trying to look at the journey of coming in with an eligibility coupon and following that all the way through to getting a first dose and receiving some badges. And, you know, while it is fairly familiar, we go through sequential experiences on our devices all the time. Surfacing these and building it and creating quick prototypes allowed us to just find gaps already and start thinking at even that screen that was just up there. If you can do a simple thing like change the orientation of a badge or print one that is contained in a circular sticker instead of a square sticker, how might that allow these different pieces to become immediately recognizable by both the administrator and the recipient in that moment that is, you know, maybe a little bit stressful or a little scary or a little new. You know, there are opportunities here to for these things to become a little bit more complex than they might not ordinarily be were we not in the scenario that we are in the world today. So just trying to keep all of these external factors in mind as we're designing and trying to work that mindfulness into the design solutions that we're creating. So again, with the idea of zooming in and zooming out, we at every moment, we're designing these things and we want them to feel welcoming and to feel accessible and not overwhelming. And the way to get to that oftentimes is in the visuals, in the color and, you know, placement, all of these things that are of course important to design and usability, but, you know, we always want to make sure that we're pulling back when we're a little bit too deep in that space and to reorient ourselves around the journey and to start thinking about some of these other things that may happen. We were recently talking about the fact that a place like Gillette Stadium might be a vaccination site. And we had this whole journey designed around starting your day as a health administrator and scanning your vaccine batch. And now you're set up for the day. You can vaccinate everyone. We know everyone is receiving the dose from this batch. But if we're doing something in massive volume or on a larger scale, you know, maybe that throws a little curveball into our journey. And we need to think about what it looks like to change your batch midstream, as an example. talk again about the different ways that we can tweak the QR codes to make them continue to be machine legible, which is obviously of utmost importance. But what can we do to aid in the human legibility of these things? Always something that we're super concerned about. The materiality of these things in a direct mail. How can we keep that consistent with what someone might produce at home if they need to make a replacement? How can we maybe make these interact with things that we're familiar with, like Google Wallet or Apple Wallet, in the same way that we're used to doing this with boarding passes, concert tickets? How might we be able to facilitate that kind of interaction while maintaining all of the security that we're concerned about? So all along the way, we're asking ourselves lots of questions, and at each moment when we're asking these questions, we're trying to create a design artifact that allows us to put that in front of people and just get reactions, and to help it feel real enough that people can give us well thought out responses, but to not be precious in any way, and know that all of these things are sacrificial and are here right now as prototypes purely for the purposes of gaining more just collective brain power into our design decisions. So, from here, we're leaving ourselves lots of blank spaces. We're in the nitty gritty of thinking about how big do these QR codes need to be versus the icon that lives inside? What kind of elements can we put around these things to really differentiate them from one another? Where do they need to live on the card to ensure that you don't accidentally scan the wrong one if you're doing this really quickly, or you're a bouncer at a venue or something like that, to ensure that they can have a nice, smooth, consistent experience in using these things? And those same mentalities will go into the digital parts of this as well. Just leaving ourselves lots of spaces to continue to explore and collect input so that we can build something that fulfills all of the needs of the people that we're serving, to ensure that this thing is as effective as it can possibly be. And I'm really honored to be able to have a part in this work, and thank you all for looking at what we've been building.
Thank you, James. And just so much thought is going into something that could be used, by significant population. And I guess I wanted to remind everybody that this is an open conversation, and there's already this question about what is a sticker and what's already printed on the coupon. So please join the Slack channel, tiny.cc/PathCheck Slack, for that conversation. Next, we have Vitor Pamplona, who is going to talk us about. We're going to transition over to the digital part of the meeting now. So Vitor and Brian Willendorf talking about the credentials, and Pamplona from PathCheck Foundation, and Vitor, exciting. So show us what the app looks like.
Awesome. Hello, everybody. PathCheck Foundation. For those of you who have never heard about us, we were spun out of the MIT Media Lab around March last year with the specific purpose to implement and take to market most of these protocols you have seen this brilliant researchers discussing here today. Back in the day, we started with a simple contact tracing protocol that was GPS-based. We migrated over into a contact tracing that was Bluetooth-based. Then we engaged with Google and Apple into the exposure notification system that they built, and we released a few apps there as well. And today we are working through the last stage of this problem, which would be, how to manage this vaccination and make sure the information of users are kept private, or as many of our speakers have said, away from servers, right? We want to keep the information in the hands of the users as much as possible. So now it's demo time. Let me show you what we actually have. Let's see if we can share here my phone. And you should be able to see an app right now. This is running on my iPhone here. You can see the app starts with a very simple walkthrough. You can see we are verifying people's age just for the sake of protecting kids' information. You agree with the terms and conditions, and then you get back to your usual dashboard. For those of you who have seen this layout before, you might have realized that this is the same layout we use for the exposure notification app, which means everything I'm showing to you here can easily be imported into these other apps to any of our partners. They can release it as in a few days if they really want to. So what you can see, first of all, is a way to insert a code, an eligibility code, which is essentially your coupon. The coupon, not sure, let's see if I can. You can either scan the same coupon that people have showed to you, the QR code there, or you can just type it in. For the sake of this demo, I'm just going to type it in here, one of the codes I have. And this code will give me access to the information that was there, of course. So it's already uploaded a scheduling request into my vaccination location. I'm waiting for that confirmation. This would be for Moderna's vaccine and the first dose. And the way we know all that is through the QR code itself. All the information, as people have said before, is in the code. It's not in any server, so we don't even need to be online for this step to take place. And then, of course, if you have if you went to the vaccination location and you get a vaccine, you can scan your record just like you were scanning. So here you can see the other QR codes that we were talking about, but you want to scan the badge, and as you can see here, I can already scan and insert into my app. So this is the proof that I have been vaccinated, at least in the first dose. And of course, you can show this card around to prove that you have been vaccinated. In the same sense, in the same app, you can use the symptom function to just log in if you have had any symptoms after the vaccination. These symptoms, as Abhishek has said, will be anonymized and will send to the servers at CDC or state servers to just allow public health departments to promote to make decisions and promote a good vaccination process there. If you wanna take a look at the app, it's available online on the Play Store right now, and Apple is just giving us a hard time, but we're gonna get there with the Apple Store as well. Let me show you a little bit of a different demo now, which is for any system that we are developing to try to connect the pieces as much as possible. So one of the applications we have, it's a simple tool for vaccinators to just perform the work they are doing in the last mile. So these are the nurses and the technicians that are in the field. They will be having a simple app from the PathCheck Foundation that will essentially log their work and help them print these badges. As you probably know, every little help the vaccination process will be helpful, and we just speed the process up. So what they do is they essentially log in, they choose their location, and from there they can just either scan the bottle or create a new record that has the lot and the vaccine name as well as location. This will be used on every new those QR code that they will be printing later on. So we know exactly what dose and what lot number we are giving to every patient. In order to record, just press record a dose. You can scan the eligibility coupon from the card of the patient, and from there, you will see, you just confirm that this code is this person is eligible for this type of code, and then press yes to confirm. You can administer the dose right now, and after you do it, you go straight into printing the badge. So the entire system is very simple and allows, or of course you can email and SMS as well, but allows vaccinators to not lose any time on IT and infrastructure, including it doesn't require you to type anything anywhere. Not sure if you have realized, but none of the things here require typing, which is a great addition to this system, especially for people that are, stressed around trying to give as many vaccinations as possible. The pressure is high these days. A similar system that we used into this app, you can see them online as well. So the app, we have a function that is just an app for vaccinators, and we have a portal for the organizations that are applying these vaccines to keep the private key and public key for the use. And let me show this to you as well, for the use, for their staff to use, right? So this is another simple portal, is the same user and password as you saw on that app. But now I have, I can register my vaccination programs, the different locations that I'm running. Say if I am CVS, it'll be each one of the CVS locations. And I can actually come here and print a QR code, which essentially allows me to place a code into my vaccine location, right? Say inside the Minute Clinic space, for instance, where users, after they take the reading, they can come here and just generate their own certificate. So if they have never heard about, an eligibility code, never heard about this card that we are talking about, they can still either download the app or just take a picture of their certificate, which can be generated from any browser. So it becomes an accessibility platform here that is quite nice for most users. In this case, you can either type here your coupon code or just your name as a user, and you would generate a QR code. This QR code is signed by the platform that is keeping the private and public key for that partner that is applying these services, the vaccinations themselves, in a way that follows our protocol. And lastly, you can also check on our website how the final dashboard for states and cities is starting to look like. And this is a very early work yet, but all the information here is live. It's coming from the states and a little bit from the app itself. But you can see how much data we can show in terms of vaccinations, in terms of who, what individuals were successfully applied to, and including of course a breakdown into first doses and second doses and so on. So this is, I think this is the demo I had for you today. Feel free to ask me any questions later on. Hopefully you can get this app approved in the Apple Store, and then everybody can play with it. But if you use Android, it's already up. You can just search for PathCheck Foundation, and you should be able to find it there. Thanks, everybody.
Thank you, Victor. Fascinating of how some of these protocols and algorithms are already in the app. With that, let me transition over to Brian Anderson at Mitre to talk about the Vaccine Credentials Initiative.
Great, thanks, Ramesh. And you can go ahead and advance to the next slide.
Okay. Just 1 second.
While those are being pulled up, I'll just introduce myself. My name is Brian Anderson. I'm MITRE's Chief Digital Health Physician, and I'm here to share a little bit about the Vaccination Credential Initiative. I briefly wanted just to share a little bit about how we got started and just the effort in general. So go ahead and next slide. One more slide, please. Thank you. So initially we got started about 3 months ago as a broad coalition of stakeholders in the vaccine administration, distribution, and broadly speaking, technology enabler space. Next slide. This is a list of all of the coalition members that have agreed to have their names publicly released as part of a large press announcement that we had last week. We have a series of work groups that include all of these numbers and those that aren't part of the public announcement. We're really excited that the group of stakeholders spans both health systems, registries, technology and device manufacturers, some of the largest health IT corporations in the world have gotten behind a very simple idea. Next slide. And so you might ask, well, what is that idea? And the mission and the goal of the VCI is empowering individuals with digital access to their vaccination records based on an open, interoperable standard. And so that standard you can find more about at vaccinationcredentialinitiative.org, but it is based on the W3C standard. It leverages verifiable credentials, and it leverages Smart on Fire. And so what can you do with this digital vaccination record that uses this open source interoperable standard? Well, just a few very upfront use cases around what our coalition rallied around. And those include just a simple demonstration of proof of vaccination. A lot of the colleagues here on the call have really dove into some of the specific user stories around how that can be demonstrated. And very excited, frankly, to be able to partner with many of you in that space. Also around reminding the second vaccine dose, when and where and what vaccine to get it. Ramesh described that, I think, really succinctly at the beginning, the importance to leverage digital validated credentials to ensure that individuals are getting those doses in a timely manner at the appropriate place is very important, as well as other downstream use cases, opting into research, being able to better inform platforms like VAERS and adverse event reporting. Also being able to support the existing IT infrastructure around vaccination registries, right? So being able to have an individual empowered with their own vaccine credential, being able to share that with their health provider, as well as with registries. These are some of the initial use cases that our coalition is coordinating on. Next slide. So I won't bother describing the problem statement in its entirety, other than to focus really on what the main objective here is, which is to have a digital certificate be able to be readily available and supported, preserving the privacy that individuals all want and demand, be it on an Android device or an iOS device, using those digital wallets that are on those platforms, as well as being able to support printed QR codes containing that W3C verifiable credential that I was describing earlier. So both a digital certificate and a paper certificate, leveraging an open source standard that's readily available on the two major devices that we have in the market today, iOS and Android devices. Next slide. So the initial use case that we've been focusing much of our work group activity around is patient or individual centric. An individual that is, in this case, as part of the user story, getting a Pfizer vaccine. It could obviously easily be a Moderna vaccine at a pharmacy. I should note that that can also be obviously at a health system or at a mobile vaccination site. They want to be able to get that on their mobile device. Well, you might imagine that pharmacy or that health system, once the vaccine is administered, being able to securely transfer that record to their Android device or their iOS device via a secure link, a text link, an email link, that when clicked on and when the QR code is presented and downloaded, can then readily be available on their digital wallet and used with their consent for any of those downstream use cases that I was describing earlier. Next slide. We're also actively looking to dive into pharmacovigilance. And this is work that we're obviously very interested in coordination with the pharmaceutical manufacturing vendors, as well as with state and federal agencies around adverse event reporting. We are also working in partnership with a number of state registries, in partnership with the health systems that are in those states, to support broadly the IIS infrastructure between health systems and registries, as well as to enable that bidirectional flow, hopefully between registries and individuals. As well, of course, and I think there's been a lot of press around this already, leveraging these digital vaccination credentials for the return to work, the reopening of our economies that we're all very eager to happen in a rapid and safe way. One of our partners, the Commons Project, has been working very closely with a number of major airline industries and the federal government in this space to use this standard so that individuals, for example, flying on United or Cathay Pacific or JetBlue might be able to use their credential as part of the boarding experience to ensure that in international travel that it's done safely. Next slide. And so this is a basic architecture, high-level architecture of what it is that we're doing. I want to start on the left and I'll move to the right. I described it as part of the initial use case. We're focusing on pharmacies and health systems who are the issuers of the vaccines, as well as, of course, the issuers of this credential. This overall approach leverages what I'll call a trust framework around it. That allows for the verification or the verifiability between an issuer of a vaccine on the left and the verifiers on the right. So as that credential is issued to an individual that can be stored on their wallet, it can also be sent to HIEs, to registries, and the like. Again, supporting the traditional IIS framework, also working seamlessly with the IZ gateway. And ideally into the CDC. Once in the wallet, though, if we're moving from left to right, again, being supported ideally with an iOS and Android devices, that can be used for the back to work, back to school, boarding of flights, etc., using visually displayed QR codes on one's device. That can also be used, again, with a patient's or with an individual's consent, moving again from right to left for other use cases, adverse event reporting, research components, reminders. These are all important enablers of that kind of digital credential. On the other end, right, so if you're an airline industry, a large capacity venue for a concert or a school that might want to have a verification process, this credential and this framework enables that kind of querying from the verifiers to the issuers to ensure that there's no fraudulent credential. That can leverage very much some of the same cryptographic technology that's been described on this call earlier to ensure and mitigate against bad actors in that space. Next slide. So I'll wrap things up really with this very simple opportunity. If you're interested in joining the Vaccination Credential Initiative, you can check out our website, www.vaccinationcredential.org. You can email that email there if you're interested in joining one of the many working groups that we have standing up. We're focused initially on leveraging this standard around the specific use cases of our partner organization. So if you're a health system, we have a health system working group. If you're a pharmacy organization or a company, we have pharmacy-specific use cases. We're also working with some of the public health officials at the state level and regional level to ensure that they have the tools, community health workers have the tools. So much of what this is about the standard, but it is also about the application of that standard in the specific working groups, of which those are some of them, to actually implement it, use it, promote adoption, and really ultimately empower and enable individuals to have freely and openly available vaccination credentials that are verifiable. You can check out more around the technical details. I didn't dive into too much of it at healthwallet.cards. That effort is led by Microsoft in partnership with the MITRE Corporation and the Commons Project. We have a whole technical team. And so if you're interested in contributing to that standard, we would welcome you, and please reach out. I think that's all the slides I have, Ramesh. It's a pretty straightforward message. We look forward to working with you and others that are interested in partnering with us along that, that mission and goal of empowering and enabling individuals with this open standard. Thanks. Back to you.
Thank you, Brian. That's just fascinating overview of how this vaccine credentials initiatives are coming together. And we need a few of these to tackle every sub-problem we're going to encounter as we reopen economies and redefine our public health. Next, we have one more Brian Behlendorf, who's leading the Linux Foundation Public Health, as well as the COVID Credentials Initiative. So Brian, take it away.
Okay, and I'll share my screen here. I think this is what they call, by the way, Brian A and Brian B, A/B testing. I might go for the pun. Apologies to everyone for that. But we have a slightly different take. Let me do a quick kind of like top-down introduction. So I'm Brian Behlendorf. I'm Managing Director for Blockchain Healthcare and Identity Initiatives at the Linux Foundation. Been here for almost 5 years, focusing primarily first on a blockchain project we've had called Hyperledger, which has actually had, interestingly enough, and kind of unanticipated at the beginning, digital identity at the core of a lot of its use cases and deployments. The Linux Foundation as a whole is a 501c6 industry consortium. It's not a charitable organization, but we do have a public benefit mission around what we do. And it's coordinated the development of not just the Linux operating system and the Kubernetes cloud container community, but also major software initiatives in automotive, in special effects houses, in telco hardware and software, in all these, in about 200 different domains. And this is our first step into healthcare and our first step into really a public-facing kind of project. So Linux Foundation Public Health, let me just advance here, was started in about April of last year, as many of us sat around and realized that getting communities to work together on common code was sometimes the fastest way to solve a systemic problem. And it was also the fastest way to drive kind of a standardized approach to tackling certain things, especially where trust was a major issue. And we felt that as these apps were to start to be rolled out to do exposure notification, to automate other parts of contact tracing, and many of us were thinking even back in April about verifiable credentials for vaccinations and such, and test results and those sorts of things, as also being a key place where trust in the technology world, which is strained right now, trust in major Silicon Valley companies, trust in the way that the internet works, obviously very highly under strain, would be put further under strain if suddenly digital health records were flying around in a way that they hadn't really been before. So we started this and focused initially on exposure notification as an initiative, and launched a couple of projects that some of you might be familiar with: COVID Green, COVID Shield, and a new one called Herald, actually, which is focused on kind of workplace exposure notification. Put the flag in the ground pretty strong early on the Google Apple exposure notification APIs as being the kind of core, the best balancing act between privacy and confidentiality and efficacy. And in fact, now have launched a bunch of services that support the EN Express approach that Google and Apple have also additionally rolled out, including analytics servers that operate in a privacy preserving way. Our members include a roster of companies that have been active in this space, as well as relationships with the public health authorities. But really the mission that we've oriented it around is how do we build software that helps public health authorities in particular in the fight against this pandemic, but also lays the groundwork for fighting, knock on wood, horribly not, but future pandemics, future mutations of this pandemic, or other public health crises. And so COVID Shield is the default app behind Canada's exposure notification app. COVID Green is the one behind Ireland's, as well as New York, New Jersey, Pennsylvania, Delaware, and a number of other states and countries. And this idea of collaborating on common code and then allowing them to be white labeled or rebranded or integrated into other people's products and services is a recurring pattern in open source software, a recurring pattern in the way the Linux Foundation runs its projects. And it fit very well here for helping give the public health authorities the technology they needed to automate EN. And now stepping into credentials. So as I mentioned, some of us did anticipate fairly early on that there would be a need to think about how to make the digital, the yellow card that all of us were so used to using before digitized, and some additional kind of concerns about privacy and confidentiality if it were to be used to gate access to restaurants or concerts or even public spaces perhaps, where the kinds of privacy balancing act that you have when you're boarding a flight to another country is very different than those other circumstances, and also realizing that we've now built through this kind of different approach to online digital identity, something called self-sovereign identity, or sometimes user-centric identity, a different approach to an alternative really to log in with Facebook, log in with Twitter, log in with your insurance company credentials, where not only are you notifying them all when you use those kinds of credentials or access that information, you're also kind of leaving control of those records up to them, and that's a very dangerous kind of thing. Instead, what has emerged in the W3C and other places are a set of standards that make self-sovereign identity and kind of the individual as the pivot point for the sharing of their records much more effective. So starting in March, this volunteer group called the COVID Creds Initiative started to pull together a set of companies that have been operating in this space, startups predominantly, other companies who had plays here, not as marquee a roster perhaps as you see on some other projects, but a lot of those companies watching from the periphery and getting involved at the point where COVID Cred came into part of Linux Foundation Public Health now, and now we've provided a proper home for them and given that effort some structure. And the main goal here is very much like we've done with exposure notification, organize the different efforts that are happening out there into a kind of a common map, help people understand what are the different reference points for deciding on that spectrum between privacy preservation and efficiency or efficacy, where they might want to land. And then going out and recruiting software initiatives to be homed at the Linux at LFPH to go and tackle some key initiatives or some key challenges in these different projects. Verifiable credentials, as this different approach to digital identity, need to stand up to a couple of criteria that both people associate with paper credentials, but also that potentially provide some benefit from being digital. Right, the user needs to feel empowered that they have control over those credentials and how they're being shared. They need some reassurance that this isn't like cookies. As somebody who participated in the HTTP standards process in the early 90s and even volunteered a standard that became the cookie standard under a different name, some degree of remorse over the way that it became a tracking device for people as they bounced around the web. And many people saw that pattern and will be damned if they repeat that mistake when it comes to digital identity and these kinds of credentials. So addressing traceability across different uses of these credentials is super important, perhaps more important than it is in the physical world. But just like with paper, it should be portable, it should be tamper evident, there should be a high degree of interoperability. I should be able to get a vaccination from a clinic in California, use it to board a plane to cross into another country, and then go attend a concert in that country, all with these possibly being very different trust frameworks or trust networks, but with an interoperability, not just in the format of the credential, but in how that gets trusted across those three different domains. And this is where it's key as you think about the three-party problem here in building the system in such a way that the verifying party does not need to have a direct integration or go through a third-party intermediary with the issuer of that credential to be able to verify its integrity associated with the person presenting that credential and being able to have all their questions answered about is this person suitable to come in, and that could be based on a picture of that person, a biometric yet lines up with who it is. It could be based on some other type of presentation of credential, a driver's license or passport, but you actually want to avoid those scenarios. Data minimization is incredibly important to trying to keep PII from leaking all over the place or having to depend upon regulation as your stopgap for keeping PII from being shared. And so wherever possible, you can get to a verifiable credential that doesn't have to access a bigger medical record, doesn't have to call home to any service. It allows you just to say, this person has received a vaccine as attested to by somebody trusted as part of this framework, I'm good enough to let them into my nightclub, into my restaurant, or into my country, right? That should be the goal that we're aiming for. And really what sits at the heart of this is the establishment of a public utility, not a company, not a nonprofit even, not a government agency, but something as coordinated. Perhaps you could think of it as similar to the way that the internet infrastructure is coordinated through a combination of trust frameworks, a combination of technologies, and a combination of organizations working together to make this kind of thing operate in a very privacy-preserving way. And so time is pretty short. I do want to leave time for conversation. I'll just mention we've got efforts both on the kind of mapping and analyzing and understanding where the different technology efforts happening here. We're not a standards body. We look very much forward to working with MITRE on how that might work, but we're also very interested in the ecosystem development side. And let me just jump forward here to show these governance authorities are the kinds of things that public health authorities will really play a very strong role in establishing. They'll have to, because they're the ones that will be authorizing the different injection sites, the different vaccination sites, as well as be connected to the parties that are badging in access to a country or otherwise being able to say these are legitimate operators. And so this is why the public health authorities we've built relationships with are key players in this. We have published a governance framework document that helps explain to the public health authorities what this kind of thing means in this kind of self-sovereign identity kind of world. And this is, by the way, the basis for many of the projects you see, such as IBM Health Pass, such as the work that Oracle and others are doing. Figuring out how to do this, though, in a vendor-neutral way, in a way that doesn't get so tightly locked down and siloed, and worst of all, would require you to have multiple apps or receive multiple vaccinations. These are all the kinds of things that we're out here to try to prevent from happening. So, long story short, lots of different work streams going on, building on top of pre-existing standards, as well as working with folks like MITRE and others. Our core focus, though, is software. We're right now that we've kind of established the landscape, engaged with a number of organizations to bring in code to serve as a wallet, as an issuer app, as a verifier app. We don't expect one app to serve everybody's needs, but we think if you can share 95% of the code, especially those that are security sensitive, you can go a long way, particularly in the interest of the public health authorities in establishing common adoption. This is how the most successful open standards have always been adopted, has been through a accompanying set of high quality reference, but production quality open source software that implements those standards. And if you are interested in getting involved, let me know. Lots of different places to coordinate, as well as just to keep tabs on what we're working on. And with that, I'll take a breath. Thank you all.
Thank you, Brian, the Brian B. And it's wonderful to see how far these efforts have come together. So that's kind of officially ends our program. But if our speakers and presenters can stay on, we can just open it up for a few questions. I know this is a topic that's of really broad interest in so many ways. At the same time, there are a lot of kind of direction, confusion, kind of coalition building. There are challenges of kind of equity and potential discrimination, and so on. So I just want to open it up and see where we go from there. I hope our speakers from earlier this afternoon can also join for this conversation. So I'll ask the first question, which is this conversation about what do we need now? Is it the user journey and efficiency, or do we need health passport? Because both these systems are not going to be deployed overnight. It'll still take a few weeks, even potentially a few months. And we have very good experience from exposure notification apps. It took between 3 to 6 months after technologists like us were completely ready for them to be deployed. So these things take longer than we think. So I just want to kind of open it up. Maybe start with Brian A and Brian B. We need to use W3C credentials at every stage. And how do you see this kind of helping the ecosystem in general?
You want to go first, Brian B?
Sure, I'll go first. Look, I think if we were here 6 months ago, we'd be a lot better off, right? Vaccinations are happening now. People are getting their cards. It's going to be tough to actually reach people who've already been vaccinated if you want to pull them into a system like this. They will if they have to do this to get on a plane to go to a country. They will if they have to do it to get into Disneyland, right? They will if they have to go back to work. So there's a tremendous amount of time pressure to be able to, particularly in the back to work scenario, get that in place. And I don't begrudge anybody who sacrifices portability, interoperability, or the kind of vendor neutrality kind of thing that I think is important here in order to get something implemented pretty quickly, as long as we avoid creating a legacy that's going to be hard to migrate away from. So there are these foundational technologies like verifiable credentials that are pretty well set. There's not really a big question about how those need to work. There's others that build on top of that, like the DID specifications and something called DIDCOM, which is a standard protocol for your wallet to talk to my wallet, to present credentials, to sign other credentials, that sort of thing. But we need a commitment from the technology industry to converge on a longer term picture that actually puts us in a best spot for the next major time we have to go and vaccinate everybody. And looking at the mutation rate for COVID-19, I worry we'll have to look at this again inside of the next year or two. You know, that we certainly will have to do booster shots at least in a couple of years for this current strain, right? And really, we should be committed to trying to get this disease to be like smallpox, something we see the back end of, rather than something like the flu that will have to persist with for, indefinitely. So I'd like us to focus on doing it just enough now to solve the immediate problems, but keeping an eye towards how do we really solve this together and create a capacity inside of public health authorities and a capacity in the industry to solve this for real.
I completely agree with Brian. My only additional comment would be I've, in many exercises in this space before, I've seen success when we focus very specifically on use cases and use case development and aligning the specific partners around, in this case, a credential around the specific use case. And it involves the airlines and the schools, but it also involves the individual using the credential and having an experience that is as delightful as possible. But it also involves using what Brian is rightly describing, importantly, the existing infrastructure, empowering public health officials, working with health systems to make all of that work and come together, and having a clear set of requirements and I think aligned principles, right? Like the W3C standard, like ensuring that we're not increasing any sense of a digital divide, that we're bringing this kind of technology to underserved communities. So I think those are the important things to consider, Ramesh, as we move this out and look for broad adoption.
Yeah. Vitor or others, any thoughts?
I agree. I think in the end, it's going to be all about how well these apps can talk to each other and how easy it is for governments, agencies, and bigger corporations to implement these protocols into their own tools. This is key for the deployment, the short term and long term.
Yeah. Brian A., given that you are, a medical doctor as well, do you see some kind of a divide between kind of the public health data sets like the IIS and BAMS and IZs versus the apps and the user-facing aspect of it? Because, the public health digital systems are all about using, the name and date of birth and name of your favorite color, all of that as part of the database to get it going. On the other hand, a lot of the things we're talking about here are privacy preserving or at least de-identified.
Yeah, no, I mean, I think a lot of work needs to be done to connect these kinds of consumer-driven or individual-driven efforts with the traditional infrastructure that we have in place. I think it affords a lot of exciting opportunities. The individuals in our society, I argue, scale much more than the 60 or so registries that we have. We have 330 million individuals. We can enable and empower those as sources of verifiable data into registries, into the IZ gateway, into VAERS, into VAMS, into vSafe. That will afford us a degree of surveillance to ensure efficacy and safety that we don't have as part of the current surveillance networks. And so I think a lot of work needs to be done, but I think it's going to have benefit on the tail end. And you've identified some of the the strong identifiers and how we go about that as just one example, Ramesh.
Yeah. So just I don't think you answered the question. So do you think we're going to live these two parallel worlds where public health IT systems will continue to emphasize name and date of birth, and then everything else we do in the technology world will somehow figure out a way to do this in a de-identified way?
It's a great question. I honestly don't know the answer. I certainly want to. I come down on the camp of wanting to, I think, frankly, disrupt the current infrastructure with the kind of consumer scalable driven methods that we're describing here. There is a way to do that safely, I think, and in partnership, much like what Brian B is doing with the public health authorities, to enable them with the kinds of tools and APIs and technology to be able to do that kind of identification work that we do in the consumer space and have been doing for quite some time. It will take some work though, but I think that's where I see us going. Hopefully I answered your question, Ramesh.
Yeah. I mean, as I said, you have both hats on, so we are picking on you. Another point that comes up quite a bit, and James, would love to hear your thoughts as at Ideo, you think about kind of the user experience and kind of human-centered design. And you have worked on many systems. So you and as well, Uni is here as well. Uni Chase from Ideo. I'm just thinking about this kind of the user journey aspect of it, and kind of just from where you sit from Ideo, what are the right ways to engage the user? Because on one hand, paper cards are kind of easy to absorb, easy to use. But apps are kind of, this cool thing that people might say, hey, this is something that's magical. Maybe, this is going to somehow save my life, or keep my health, digital health life as fancy as my life on e-commerce or banking. So this spectrum of keeping it low tech, but possibly effective, to all the way to apps. How do you see that user journey in this complex vaccination round?
I mean, my initial sort of response to that is that, there isn't necessarily a solution that fits for everyone. Like, there are people who have a very comfortable relationship with technology and their devices, and they've kind of come to grips with what the realities of privacy on the internet are, even if we're promising something better than what they might experience elsewhere. I think there are a lot of folks that would accept the convenience and the, at least like, personal centralization in their own life over what might be the burdensome way of carrying around a card that you have to keep track of, and managing stamps and so on. And then there are obviously people on the opposite side of the spectrum, people who really need these vaccines badly, who don't want anything to do with the technology, or just aren't comfortable enough with it, or maybe they're comfortable with using the devices but not in this context. So I feel like the idea of kind of opening up the conversation to people through a physical piece and allowing them to kind of choose their path that way seems like a way of maybe grabbing the most people. If the initial way that you become aware of this is through a physical campaign, maybe there is a digital campaign that accompanies it, but allowing people to have an equal experience that doesn't really leave anything behind, that you're able to choose based on your level of comfort, seems like the ideal for me.
Yeah, even at airline check-in counters, you can always see there's always a significant fraction of people who want printed boarding passes. It just makes them feel like, hey, I actually have a seat, in case my battery runs out or something like that. So that's that's kind of an interesting point. How do you see it, Brian B, on this low tech versus apps and so on?
Yeah, so I'm on the Technical Advisory Council for ID 2020, which has been operating now for a couple of years, focusing on identity approaches for scenarios like refugee camps or for social work in underprivileged, other underprivileged circumstances. And there you have to design, in fact, it's been a core part of the requirements for people who don't have devices, they have, they don't have smartphones, even if they do have phones, those sorts of things. And so you need systems that can devolve to paper. And where somebody can just carry a card with them if they need to, and that is it's tough, right? Though, because if it's just paper based, there's certain use cases that might be forestalled. If we want to address the traceability requirement and avoiding this kind of super cookie problem, then we want to make sure that when you present a credential, if you can present it kind of in a case by case way or different credentials for the different settings that you're in, that's a lot more secure. Something that's tailored to the situation. It's a lot more secure than showing the same string that can be, copied by hostile actors and used to connect you. So you have to look at this holistically for sure. You do have to be able to design to go and meet the full population where they're at. I don't think we should be afraid of technology and adopting that or take a Luddite kind of approach to it, but we should be skeptical, and we should be skeptical about the power dynamics that that currently exist today in the internet, and try to avoid kind of the centralizing effect that some approaches might take versus others. So I think you do have to design for everybody and address people's concerns about trust, whether digital or analog or otherwise.
Yeah. And I'm one of our world's experts in credentials and identity. What's been experienced in the real world scenarios where, you have options between something that could work for the masses, but it's low tech and could have issues like traceability versus high tech that, could appeal to a smaller population, but is more secure. What's been your experience? Any analogies you have some other fields where rapid deployments has faced these hurdles?
Are you asking me?
Yes.
So I think that a lot of these cryptographic possibilities are new, but they're on the cusp of getting widespread use. And especially in the last few years, we've seen cryptography popularized with technologies like Bitcoin, to the point where people are feeling a lot more comfortable with the concept. So I think that even as Brian said, there are some populations that are more comfortable with paper-based things and some populations that are more comfortable with apps. I think that we are at a point where people have come to understand that there is such a thing as unforgeable credentials and that they can exist on both on paper and in an app. And usability is kind of a separate concern. Designing it, like James outlined, having a good design that is that people understand how they're supposed to use it. I think that's the important question: is can we step aside from the technology and think from the point of view of the user? And are we making the technology so straightforward that the user can just say, oh, I like carrying something in my wallet, I'm going to use paper. Oh, I prefer to do everything on an app, so I don't have to look for my piece of paper. And then they don't give it a second thought. And I think that should be our goal. And whatever complicated stuff is happening under the hood, whatever privacy preserving features we put in there, this is something that we can communicate to the population. We can pat ourselves on the back, but ultimately, the most users are not even going to think about it. They're just going to say, oh, this is the way I'm doing it because that's the way my best friend is doing it. And so I'm just copying whatever they're doing, or whatever other private reasons they might have for it. They're like, oh, I'm going to use the app because I really like the cute little icon that you put in there. And whatever reasons that they have for doing what it is that they're doing should just work just fine for us. So, and as far as the crypto, everything that's under the hood, I definitely wanted to give a shout out to Brian's work in the Hyperledger and just the kinds of things that are in that software library. That's a really damn impressive software library that you guys have put together. I mean, it has very advanced cryptographic tools, very things that are state of the art that needed to be implemented so that we can all use it. I mean, it's there. It's amazing. So I think that I mean, I have very, very high hopes for this entire piece of the puzzle. All of these pieces of the puzzle fitting together and making the world a better place.
Continuing on that thread, there's a question in the online chat as well on the technology side, which is, we're talking about somebody has to certify, somebody has to give the credentials. A simplified version would be a state or CDC could do it. A decentralized version could get pretty messy very quickly. What's the thinking there? Victor, I know you have worked in this space. Brian, of course, Hyperledger has. What's the philosophy in the vaccination space? Are we thinking there are, a dozen of these players or thousands of such players? And how's that going to play out, Brian?
Are you talking about the registries, the IISs, or?
I'm talking about who gives the credentials, who can certify the credentials.
Who can certify?
Highly decentralized or just a few handful of entities?
Well, it's it's got to federate down at the level of a state or a country, but it also has to be shareable between countries, right? If my use case is that I get a vaccination in California from a clinic that's probably authorized by the California Department of Public Health, but wants to interoperate with other states, and so there's some involvement in the CDC at a kind of lightweight layer. But I want to use it to board a plane to Canada and then attend a concert. I want those trust frameworks to be transitive, right? I want the United States and Canada to be able to agree enough on kind of common principles for who qualify as issuers of these kinds of vaccination records, so that Canada, the border authority in Canada, trusts that. And then I'd like within Canada there to be enough trust between those authorities and the people who validate those credentials to attend a concert or whatever, that it's basically transitive, right? And it looks something a little bit more like the PGP Web of Trust model than necessarily looks like the TLS certificates in the browser hierarchies, or even more decentralized than the domain name system. The domain name system that we have today through ICANN, and that is about as close as we get to the most lightly federated, push all the hard work and the complexity to the edges and have a core that is very lightweight. And I think that's what we can get to with organizations like the WHO playing a lightweight role in orchestrating and authorizing connections between the trust frameworks and kind of green lights to different standards devised elsewhere, devised at MITRE, devised at W3C, but also saying, hey, this is kind of good stuff, and maybe IATA should pay attention to this, and kind of building up kind of organically how those work. There'll be a lot of pressure for that interop as soon as people are back on planes again and wanting to attend conferences and that sort of thing in foreign countries. There'll be a lot of pressure to converge, and what we hope happens is that it's an organic kind of thing, much like the way the internet came together, with just enough lightweight coordination between entities to make it happen quickly. The harder question is that grassroots bootstrap. It's where I really like the coupon approach, because I think that does bootstrap things very quickly. Just figuring out how to do that in a way that meshes with privacy and the trust framework questions is I think a challenge I'm eager to work on with you, Ramesh and Brian and all the rest of you.
Yeah, we are almost at the top of the hour. If Victor or Abhishek, if you have questions, I have one more question, which is this notion of, you call it kind of a lightweight federation. So are you, Brian, this back to you, are you imagining a credentialing scenario where there is either WHO is kind of like the ICANN, and then there's kind of a second layer of certifying entities, and then everybody kind of hangs off of that?
I'll just say we need to find ways to approach this with minimum viable governance to avoid the need to have too much structure at the center. And fortunately for us, although usually it's unfortunate in other circumstances, the healthcare systems of the world are highly fragmented, highly distributed, highly pushed to the edge. Even in the United States, it's much more in the states and the counties than it really is on the CDC and FDA in terms of a coordinating a top-down kind of effort. Maybe that's even changing a little bit after, in about 24 hours, we'll see a different tone in Washington. But even there, I think they'll be most effective if they say, right, we're not coming in to tell everyone how to do their business. We're coming in to make the most of the distribution that we have today and how things are run, and looking for opportunistic ways to align everybody. Minimum viable, but get to, at its heart, we don't need to be talking about sharing full health records. We don't need to be talking about really high degrees of trust. Really, the more we practice data minimization, the easier it will be to federate a trust network.
Good. Vitor, Abhishek, any final thoughts or questions?
One quick question I had was around like the usability of this whole ecosystem beyond vaccination, because some of these things we are doing here can extend to normal health records beyond vaccination. So maybe question to Brian, where do you see, especially with the identity and related stuff?
I was going to defer to Brian Anderson on that because I feel like as the MD, he's probably better. But did he drop?
He just dropped.
Oh, I'm sorry. Okay. So I spent 2 years working for the Department of Health and Human Services on trying to make health records more portable. I know that's been a holy grail for the health industry for 40 years. I know that's sometimes been stymied by some of the major health record software vendors out there. But also, like, the real issue has been trust. These records flying around, deeply PII, perhaps the most sensitive PII possible. People have appropriately been concerned about not wanting to make that too liquid, too easy to share those things, right? But trust has been the kind of the forgotten ingredient in internet architecture for so long. So if we do it, we have to just have a much higher degree of trust when it comes to information sharing, and centering that on the patient, on the caregiver, on the individual, rather than centering it on the HIE or on the insurance company or on the clinic or on the health net, on the provider network, is critical to building that trust, I think. So if we can get to that, and the patient as the center of health information exchange, I think we'll be able to get to richer sharing of health records. But if we hold that up as the standard for doing VAX records, that may be hard. We may be aiming for the perfect when the good enough is around the corner.
Certainly. All right. So I think we're at the top of the hour. So we appreciate you all joining. Please continue to join the conversation at our Slack channel, tiny.cc/PathCheck Slack. We'll be back next Tuesday, January 26th at the same time to hear about work going on, of course, in paper cards and verifiable credentials for the whole user journey, as well as work in simulation and modeling and dashboards of keeping track of vaccination, some of the privacy-preserving aggregation work that Abhishek was hinting at, and other collaborations that are emerging in simulation modeling and prediction as well. So I want to thank all our speakers who participated, as well as many organizers and teams that have brought this show together. We'll see you next Tuesday. Thank you.